Hello, welcome to Aruba Atmosphere 2017. My name is Tom Hollingsworth and I am a part of Tech Field Day. We are here with a group of invited delegates to take part in a roundtable discussion all about mobility and wireless and some of the exciting things that we've heard here while we're at the conference. If you'd like to see more videos like this, please make sure you check out our website at techfieldday.com. You can also see our YouTube channel at youtube.com/techfieldday. I'd like to take a moment for the panelists and delegates to introduce themselves to the audience at home. Keith, why don't you go ahead and start?
Keith Parsons with Wireless Sound Professionals. I do Wi-Fi. You can find me on Twitter at Keith R. Parsons. My website's wlandpros.com.
Shaun Neal with Brickworks, and you can find me on Twitter at SV_Neal, or my blog, blog.svneal.com.
Sam Clements, social media blogger at sc-wifi.com, where you can find me on Twitter at Samuel_Clements.
Blake Krone, you can find me with no dashes, underscores, or anything crazy like that, because I like to make it easy. BlakeKrone.com and at Blake Krone on Twitter.
Eddie Forero, Communica One. I have a blog at badfi.com, and I'm on Twitter at Hey Eddie.
I'm Joshua Williams, a Wi-Fi practitioner in the middle of the country. You can find me online at 802.me or at 802.me.
I'm Ryan Adzima, at Adzima on Twitter, wireless engineer and blogger.
I'm Drew Lentz with Frontier Consulting. You can find me on Twitter at wirelessnerd or at wirelessnerd.net.
All right, thank you gentlemen for joining us. I'd like to kick off the discussion today with a topic that is all about the future of technology, machine learning. During the keynote today, we heard a lot about some of the new advances that Aruba is making in analytics, machine learning, artificial intelligence, and how it's going to make all of our Wi-Fi lives significantly better. I have some thoughts on this, but I want to hear from the delegates. You know, what do you think the impact of machine learning is going to be on Wi-Fi over the course of the next 3 to 5 years? Eddie, why don't you start?
Well, I mean, that's a good question. So right now, it appears that at a high level, it looks like they're really looking at taking this machine learning, kind of taking a broad overview of what the network looks like, and kind of understand what looks like a good network, what looks like not such a good network, what are the commonalities, what are the differentiators, and then provide you with an assessment and say, this is where you're at now. To be where you want to be, try this. So I think that's kind of how it's starting out first. I think when we first heard about it yesterday in the keynote, kind of, at least for me, the wheels start turning. I'm like, oh, this is like that stuff we've talked about like several years ago at like WLPC, right? Where it's like self-healing networks. You know, it's like this AI that kind of learns how to tune a wireless network. We're not there yet, and they're not claiming to be there yet. But I think they're saying this is the beginning. This is where we're learning how to create something that can have add some intelligence to the infrastructure. So it's pretty exciting. It's pretty exciting. Especially with the complexities that are coming up in the next several years with changes in how Wi-Fi works. I think it's going to be very important. There's going to be a lot of things that maybe we just can't handle as wireless engineers as quickly as we would like to, especially in changing environments. So I think that's probably that's where it's headed. But right now it's exciting. But it's very early.
Sam, what do you think about this?
Yeah, I think the panacea of having a self-healing network, right, is the long-term goal for everybody, and I think that this is a great first step. I think that even just having the intelligence to raise a flag, saying, hey, we've watched your network over the past, whatever period of time it is, and to say we notice a deviation above what the way your network has been functioning. It allows us to say not every network is different, and we've sort of known that's been the case for many, many years, and it's been the problem, especially around things like best practices, because best practices takes a one-size-fits-all, and everybody should go and do fill in the blank. I think this is one major step forward towards the end goal of a self-healing network. But giving us the visibility of saying, hey, you've got something that's interesting for your particular deployment. Hey, you maybe want to go knock that mole down, right? You maybe want to go make a configuration change or watch and see what this next thing does to see what your baseline does, if it returns back to normal or if it even improves some or gets better from a quality of experience perspective. It's a major step forward.
Drew.
I think it's great that to see that Aruba's moving in this direction. There've been a couple products that were introduced on the market that showed some of the some earlier software, year or two ago, and nothing has really come to market that's been a huge. I don't want to say success because the companies are successful, but there hasn't been any driving force behind it to see something that's more polished than what we got an opportunity to preview last year is now fantastic. So there's definitely a trend with what's happening with computer learning or machine-to-machine learning, but taking it kind of out of the lab and putting it out into a production environment is great to see from the wireless perspective. I know we looked at it from the wired side, but now the combination of wired and wireless moving forward to machine learning, I think, can only make these networks better for all of us.
Cool. Keith, you're the godfather of wireless. What do you think about this?
I couldn't even do a good imitation there. I think machine learning is finally getting us to a point where we can start applying it to actually solve problems. It's been a long time coming where people still make really bad decisions on Wi-Fi, using 40 megahertz channels where they shouldn't, changing their minimum data rates where they shouldn't. And if we can get anything that will help that lower tier that don't have experienced professionals on site to make them make better decisions, I think that's a very useful thing for machine learning. But the more we get into this, and we've been doing this 16, 17 years, the more I learn about Wi-Fi that it's just getting more and more complex. We need the machine learning to offset even what experienced people do because it's getting too complex for us to handle. I would love to offload those dumb questions that we keep getting over and over again to something that can be more automated. So hopefully that's the way it's going. But again, we're still early on. And just one comment from what I've seen, it's almost a repudiation of the whole RRM ARM issue because every one of these issues that has machine learning in it, they've put a human back in the loop. On the security side, on the performance side, that we'll do the machine learning and grab all these analytics from thousands and millions of data points, but we still have to tell someone to do it because we're not confident enough to have it do it automatically yet.
Shaun.
Yeah, I think Sam talked about best practices too, and there's a whole component of this where it's about the mix of devices that are in your network, right? And for the first time, this really gives us the ability to potentially crowdsource data, right? So certain devices look a certain way in a certain environment. We would expect them to be similar in a different environment, but if there's some way we can start evaluating that data at sort of a macro scale and trust that our vendors may well give us that sort of feedback. It's an area that is, network administrators is really difficult to stay on top of because the churn of devices happens so quickly. That if we can trust some of that data, I think it would definitely make lives easier for a lot of people.
Ryan, Blake, you guys want to jump in here?
Yeah, I think machine learning is great when applied to the data sets that we are able to pull out of the network, the telemetry, the performance, all of that. But I think the expectations need to be set. This is not automation yet. This is analytics applied through intelligent systems and recommendations are made. Like you said, it's bringing people back into it.
Well, we used to just call them expert systems.
Right.
And we used that term expert system for a decade, and now it's machine learning. But it's really, how do we put that intelligence into the machine?
Well, how often have we heard RF engineer in a box?
And that's what I was going to say, is that the RF engineer in a box, none of this is going to replace us.
Well, even when it can get to that point, do we want it to?
No.
Because there's the I don't know, the thought, the little game that philosophers play with automation. You have an autonomous car, and it's driving down the road, and you have a group of school children that walks out in front of you. The car has the choice, kill the driver or kill the kids. Who does it kill? What's it going to do in a network? How do we train it to make the right decisions properly? Because that's the human part of it. So that's where we're not there yet by any means, but when we do get there, are we going to let it take over and kill the CEO's connection in favor of everyone else's?
Well, I think there'll be a hybrid approach of, I mean, it's just like RM and ARM, like you said, Keith, today, is that we use these tools, but as we all say whenever we're doing our talks and presentations and everything, it's always RM or ARM is only going to work if you tune it. So if you take the time to put in the information and tune the parameters so that it matches your design, it can succeed. So how are we going to apply this to that decision-making process, like you said, of where do I choose? You know, looking at some of the things that they're doing today during the keynotes and stuff, and walking through it and trying to figure out how does this machine determine which AP to power down for an upgrade right now versus another. Well, how do we work through and come up with all these different logics? It's never going to replace any of us, nor should it ever replace all of us. It should assist us and provide us that feedback loop to make smarter choices. I agree with Keith that there's some lower end, that low-hanging fruit, the annoyances that we constantly have to have conversations about of whether or not we should do this. It can automate some of that stuff, but the big decisions, it's more of an alert platform then.
And I think that's where the demo shined this morning. I would take issue with the slide where it showed the machine learning process, and then it had the person, and it dipped down and showed that the API could do what the person did, and then went to the end of the process. I think that should have been in line with it. And even in the demo, when he used Amazon Echo to shut down the user, or to get the user report, then Twilio to shut the user down, there was still that human interaction that was done because of the information that was gained from machine learning. So I take issue with the way that it went around the human instead of replacing a human with an API, using that data to help drive a decision process.
So let me ask this question, because this is actually something that I've kind of been curious about. There's actually a very wide gulf between machine learning and AI. Machine learning is taking a bounded data set and drawing decisions from it. AI is breaking out of a bounded data set to infer things. My favorite quote, thank you, Internet, is intelligence is knowing that a tomato is a fruit. Wisdom is knowing you don't put tomatoes in a fruit salad. Intelligence is what we're getting from machine learning by taking all of this information and applying what we consider to be best practices to it to say things like the CEO should not be running a BitTorrent server in the office. Wisdom tells us, and AI is what's going to have to learn, we don't boot the CEO's connection in the middle of a conference call because he's on a personal telepresence box and it just happens to look like BitTorrent traffic to us or something like that. Do you feel that eventually we can train an AI system? I'm not talking about machine learning at this point. I'm talking about taking that and applying it to a construct that says, I can think like an engineer and I know when to make the right decisions and when not to.
I think that we are very far away from that.
Yeah.
Sure, we have machines that can virtually pass the Turing test right now, but are we able to have machines that actually think like humans and know the difference? Think like engineers and know the politics behind all of that. Politics is something that even adults can't be taught sometimes. So I think it's going to take a long time before we get there, before AI can get all of the intricacies of human experience.
Well, and I don't see this being a Wi-Fi problem. I mean, look, you apply the same question to, I've run out of resources on a server. When do I instantiate another AWS instance with more memory and more CPUs in order to contain, or in order to service a rogue process, right? I mean, extend that out to data center or wired infrastructure or collab tools, or pick a technology instance. This isn't a Wi-Fi problem. This is a technology problem.
Do you think that technology changes too rapidly for us to ever be able to truly get enough models to be able to actually make these decisions?
So I think that's the brilliant potential of what we're looking at today and in the very near future, is that with the machine learning and the AI that we can apply to that, we can get at patterns of data and patterns of behavior that it's difficult or impossible to model in a lab when we're trying to build an RRM algorithm. But if we can look across an entire enterprise environment and look at the characteristics, the context that make that enterprise environment unique, and then see patterns with that a human being or a team of human beings can't. I think there's a lot of power in what that does for us in terms of informing designers and engineers and troubleshooters of Wi-Fi. And then even beyond that, I mean, the next step would be, to your point earlier, Sam, not all Wi-Fi networks are different, right? And we focused a lot on how they are supposed to be different. I think you bring up a great point. What makes them similar? And if we can find those patterns across different enterprises and go from collecting information from hundreds or thousands of clients to millions of clients, the machine analytics can really give us some great insight, I think, into how,
There's so many privacy conversations and challenges that go along with that, though, and not to open up a can of worms, right?
That's the difference between machine learning and artificial intelligence. What was the quote that you said earlier? Jurassic Park. We were talking.
Oh yeah, just because you can doesn't mean you shouldn't. Or,
there's and Blake, to your question, there are a lot of things that we can do, but there are so many things that we shouldn't do, and that can be dangerous to the users.
And I think the trend that I like, the trend within the trend on this is exactly what you guys are talking about, where they mentioned empirical data, right? Taking other similar sized companies or other similar sized atmospheres and grading what's working with you along that. We've heard that before. And
atmosphere is like environment, not conferences.
Not atmospheres like environments, not conferences. But taking that so that you know where you stand overall. I think that's one of the important parts where you mentioned being able to collect that data and model it accurately, anonymizing it, right, as being one of the key things there. But I think that's what adds to it. It's not just what does Keith think is good, what does Blake think is good. It's what is happening in the environment across a multitude of users, and how do I fare as a restaurant or as a hotel or as a small business? Am I doing more or less the same thing that another counterpart is doing, or am I way off the grid? But even at that, I mean, who's to say no two restaurants are the same, no two hotels are the same? So
I would like to comment on that and say one of the things that Josh just commented on. I think we're going to need AI and need this because the complexity that comes into AX, none of us can ride on top of. Without that extra intelligence that we're going to have to rely on, how do we know what BSS coloring rules and split spatial streams with upload and upstream and downstream multipath? We don't even have the tools to look at it, let alone understand it. We're going to have to rely more and more on the technology to feed us back the results because the complexity is off the charts.
By extension, though, you're essentially assuming that the systems we have today will support the complexities of
I'm sure
tomorrow.
hoping it does.
Well, I am too.
I think that's the play, right? So I think the takeaway from like the keynote, it's kind of like going to Disney World, right? And you have this, that's the world of tomorrow, right? or pretty much any Microsoft product video, right? This does not exist, but wouldn't it be cool if it did? And so I think that's the kind of the takeaway is, we have machine learning, right? We acquired Raza. We're going to add this into our product line and have it feed us information. But I think the takeaway is it's not. We want it to be AI. We want it to do automation. But I think the initial goal is we need a tool that's better than us, like Josh said, finding patterns, finding similarities, measuring the differences, right? And saying where's that best place to be. So it's really data analytics is what we're looking at with the machine learning. I mean, way down the road, is going to be before we start automating stuff. I think for a long time it's going to be really just the way that a software can very quickly analyze those things that just humans just can't.
You think it can solve something that Sam's famous for saying? It depends. So a lot of things, it depends in the wireless world. We have to say that all the time. Yeah. And yet there's some underlying core principles that I might say, don't do this. And you say, well, it depends. What about this corner case? Well, then I would change my mind. That's something we can teach and have those it depends automatically follow principles and keep us from being a slave to all the little nitty bitty things.
Well, the great thing about machine learning is machine learning follows whatever rules you give it. And it gives just data. It doesn't have an opinion. We're not asking for an opinion, we're asking for numbers. When we're looking at the probability that a certain design will work or won't, or is having an issue or isn't, it can model that. We can give it, these are the boundaries of physics. These are the rules of 802.11. This is how my network is designed. Tell me what to do. Show me the probability that these changes will
Would
make
you
it
would
better.
you accept, rather than just the probability, why not have it actually run a test? We're collecting all these statistics. For this scenario, in this left-hand side of the cafeteria, we have co-channel interference. We should change to 20 megahertz channels and lower the power rate. Run it and see what the retry rate is. Swap it, check the retry rate, and automatically tune itself to have the lowest retry rate
And
and the highest
that's just
throughput.
one step further than the modeling is, okay, I've got these 3 models that I think are best. Let's test
But
it.
I don't want to be there going test, 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 test,
No,
test.
no,
Give me the answer.
absolutely.
The principles are there. Can we automate those pieces and add a little bit of intelligence to offload those simple things?
But then just a little bit further than that is putting the driver into a brick wall.
Yeah, but none of that takes into account, site-specific performance accommodations, if you will, or politics. Right? Yeah, you can machine learn all day. If you machine learn what we believe a terrible network is to be, but it meets your user's application or performance requirements, how are we to say that you need to flip this widget or you need 50% retry rate is bad? Well, if it meets my application requirements, and oh, by the way, I don't have to deal with the politics of making all these changes or dealing with more channels or power levels or whatever, it depends, right? And that's something that's going to be really
depends
hard.
for decades more.
I know.
So I think Shaun had some thoughts here. I want to give him a chance to speak.
Yeah, there's a couple of things I wanted to chime in on. So one is I think the machine learning is going to let us address a certain subset that's difficult to engage with today, right? We talked about a lot of these user engagement. There's a place like this or somewhere like that, there's a good portion of the users who there's not really an opportunity to get an exchange with, right? Like we don't get to have their feedback on whether or not the wireless works, but if it didn't work, then they may never come back, right? So I think machine learning gives us a chance to understand what's going on with a demographic that we can't necessarily engage. And outside of just users, I think, Keith mentioned AX. We see AX really being developed to support Internet of Things, right? And that proliferation of devices that are going to be, cheap, right? Potentially bad clients, understanding how they're using that space and with a protocol that's very complex by comparison to what we have today. I think that's going to be a necessity, right? To really understand the experience of those devices and whether or not they're meeting application requirements or anything along those lines.
I want to take a moment here and ask if there are any questions in the audience. Anyone have any thoughts?
Hi, my name is Sean Bender, and I have a question. Do you see the machine learning approach as a way to push the sales of more hardware to be local versus more cloud-based? Since everybody was kind of pushing, hey, let's put all the thought of the AP in the cloud, but do you want to put more processing power local? Well, do you feel a way to push more hardware that sells that way?
Sam, jump in here.
Yes, so with great power comes great responsibility, right? I hate to be all platitudes about it, but at some point you have to put some thought behind the recommendations that are being made. And if that recommendation is more hardware, there's a perfectly legitimate use case that demands more hardware. And that may be a perfectly correct recommendation for an environment that's not working correctly. But I think that type of a conversation borderlines on the same concepts of, hey, you're running out of storage space, I'm going to go ahead and have the server auto order me a new hard drive that meets whatever capacity path we're on, so that when it comes in, you can go ahead and put it in. Well, how do we know what that storage concern is? Is it somebody just, making big swap files or, I don't know, data center stuff, right? Words, big files. But, at some point, we as humans have to balance that automated recommendation, whether it be configuration tweaks or more hardware or more widgets or newer boxes or later versions of code or features that we may or may not need or may or may not be compatible. That's the piece that we all have to know.
Blake, you jumped in here.
I was basically going to say the same thing as Sam did, that, yeah, high five, go us, go Team Broskies. No, so yeah, why is there the need for the more hardware? That's the more important question, because did your design not meet the requirements from day one? Now, is it going to push more intelligence or more people to go towards cloud versus devices located in your data centers. We all keep hearing that local data centers are going away and controllers are dinosaurs, yada, 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 et cetera. You can talk through all you want on it, but that's all a design choice of what you want. I think what Aruba is trying to do here is looking at it, and they're not ever saying this is all going to be cloud. Everything's going to be cloud. You have to go to the cloud. Be prepared to go to the public cloud. They're looking at it as how can we take as we saw in the keynote today, how can we take the things that are running locally, your software today, and provide a solution that could go to the cloud as well if you wanted to for mixed environments so that you can run things like Aruba Central and still have these intelligence that you have if you have the local box. I don't think we're going to see people force down one particular path. I think it makes more logical sense to give people options, because if you force them down one path, you act like other vendors that don't have solutions that scale, or they scale poorly.
I think maybe you can just repeat your question, Shaun. We were saying these machine learning pieces, do they require more hardware?
That's what I got.
And a lot of them need something that's going to aggregate and compress before it sends it off the cloud for processing.
But
Yeah.
why should they?
Well,
Keith,
I
in
think
a
that was his
way-
question. Do they require that?
In a way, but was it more of a sales pitch to say, hey, we've been pushing all this information to the cloud, however, our sales for the local controller are going down, so do we want to make this happen? Do we need a way to force people to sell more hardware? I mean, how many tweaks and knobs can you turn to improve a wireless?
Are you talking selling more data center hardware to compute or more access points?
It could be more access points. It could be, if you're adding more access points, well, you need more, thought process to go with that, and maybe you do need a controller. But if everybody was pushing towards the cloud and then people realize, hey, wait a minute, we're, reducing sales of all these, let's say the higher margin compute processing, the controllers and things like that, maybe we need to figure out a way to add more intelligence into the AP. Instead of shipping it to my data center, let's put it in your building.
Well, I
Let me
think
sell you some hardware for that.
I think the thing that Rasa's looking at is the selling point, or the power kind of behind of the data collection, is that it's not your site. It's aggregating data and looking across different environments. So it's not just you. So it has to be, there has to be some cloud component, because it needs to compare, University A against University, University East against University West against University Central. What environments are the same? I see that you guys have similar environments that are very high capacity, maybe auditoriums and things like that, as opposed to maybe smaller classrooms. You guys have different needs. What's the similarities? Okay, well, these high capacity areas, you're different customers, right? You're different environments, but you have similar environments within each of these locations, and then we're going to use that to build that machine learning to see, well, what works that's similar across these. So I think you're going to have that cloud component always there. As far as the hardware on the ground, I mean, I think that's going to stay the same as far as how it's been now. If you need more APs, you get more APs. If you need more processing power because you have more clients, faster, more data being transmitted, that's one thing. But I think you decouple the machine learning from the wireless. The machine learning kind of influences and the infrastructure, but it's not in the infrastructure. It has to be computed somewhere else, because it's gathering that data from. I mean, that's kind of what I intuited from what they were telling us. Is that
Brian,
correct?
what did you have to say here?
I want to flip that question on its head.
Oh.
And what if you have one of the handful of 70 to 80,000 seat stadiums in the country and have really valuable data? What do you get for contributing that to the cloud?
Yeah, that's kind of my take on it too, is that data is.
I have a 100,000 person university. I can give you data from every kind of environment you can think of. What are they going to give me to hook up?
We'll make your network better.
We're going to make your network better.
Are they though?
Well, I mean,
That's the whole
that's the
value
sell, right?
proposition.
That's the
That's the
sell.
hope.
If I can make your network better, is that value worth?
But what if
you
I'm
giving
already
me the
meeting my
information?
client's requirements?
Yeah, comes down to is if you're meeting the requirements.
What if you're two NFL stadiums and you're trying to get a competitive edge on each other? And you've got the stadium with the working Wi-Fi, and I don't.
Well, they just say we have Wi-Fi. They don't say we have Wi-Fi that can do X, Y, Z. It's just.
But I think also with Shaun, with your point, is that on the additional hardware stuff, what is the processing power of an access point today? How much are we truly tapping into those resources? These things are becoming pretty much power horses, and we've gone from having really powerful APs with all the brains in them to pulling all the brains out and going to dumb APs. Now we're still putting processors and more RAM into them. There's cycles to be spared, so why not a distributed intelligence as well?
I'm going to let Sam have the last word on this question.
So my question is maybe a different perspective, which is, the logical conclusion of that is, hey, I as a manufacturer am going to roll into an enterprise or a customer or an education environment or fill in the blank. I'm going to say, your education, you support 30,000 students. I'm going to hang a sensor, and then I'll be back to you in a week with an automated generated bill of materials so that machine learned what your environment should look like. Here, go buy this. Because that's really what we're talking about. If we're talking about machine learning what an environment looks like based on broad sample sizes of equal classifications, all of your architecture should ultimately look the same, right? Mm-hmm. In which case, where's the competitive differentiator? If your goal is to make University A look like University B because they're equal, similar sizes, I'm going to hang a box and we're going to baseline. And then we're going to come back and we're going to note because of X, Y, and Z deviation, you should look like this. Here's your cookie cutter design. Boom, go away. That's not a world I want to live in.
Nope.
Well,
But I think that's
can we stay on this just one more minute?
Sure, why not?
another 10 minutes.
I kind of land just short of that with it right now. And I think the potential one of the potentials of machine learning in broad data sets that we can analyze is that we can, to the right degree, potentially take human bias out of some of our decisions. Because we all come to the table from a design or a configuration standpoint with certain biases, or even from a troubleshooting standpoint, because we're human beings, and human beings influence algorithms. That's how machines get biases, right? They get the biases that we give them. But if we have huge data sets and we have even machine learning that can wire around that to some degree, or to wire around that to some degree, I think what it does for us is it gives us better recommendations, but I don't ever see it taking the engineer out of the process. I sure hope it doesn't, because at the end of the day, as has been pointed out several times, we have to deal with layer 8. Right? We have to deal with the politics, the budget, those difficult
Computers
human
don't fight
elements.
back like engineers do.
Nobody,
I, for one, welcome our robot.
nobody ever expects a Spanish Inquisition, right? You don't expect what it is you're not looking for, and I think that's the problem.
And I think we have to be aware of it, absolutely.
Yeah.
Oh, next.
Our chief Wi-Fi weapons are fear, and
Yes.
is there anyone else with another question?
I'm Anish Verma. So having this machine learning and all the knowledge of it, wouldn't it be more advantageous to have it during the Wi-Fi planning and the deployment instead of just using it after you deployed the whole Wi-Fi?
I'll tell you, I think it's going to, you can design all you want, but in the real world, people move, they change patterns, they change hardware, they use a different device, apps change over time. And I think that's where we're going to have the machine learning augment. We can have a fantastic design for today, but designs don't morph. So knowing that I don't want people who are walking on the sidewalk to associate, I don't know that when I first do my design, but the machine analytics could come back and tell me, you get 80% of your connections are being used up by people who are associating but not sending any data. Why? And that piece of view of my network, I can't get normally. So I think you can have great design, but the analytics are still help us adapt our designs.
Ryan?
Yeah, I think that's when we would move into the artificial intelligence part of it. There's still a lot of art that goes into design. Like you're saying, there's, it's not cut and dry. There's a lot of what if. It depends. There's too much of that right now for machine learning to be able to just spit out designs. We have auto planners. They suck. that's when we would get into artificial intelligence, and that's when it would be taking things into account like future growth and projected patterns of movement throughout environments.
But doesn't take into effect the sconce or the chandelier or the tiered
Well,
ceiling and the
garbage in, garbage out.
the aesthetic.
You gotta give it enough-
Analytics don't mean insight.
Yeah.
Right.